Welcome to Study Loop.
We are asked to consider the safe drinking water for arsenic. And we are given that the safe drinking water standard in most developing countries is 50 parts per billion. We are asked to calculate how many grams, let me switch colors, how many grams of sodium arsenate are in 55 gallons of water, which is a drum of water, if we have a 50 part per million arsenate concentration. And that's not too tough to do here. The first thing we're going to do is figure out how many grams of arsenate we have, and then convert that to grams of sodium arsenate. And that is going to be a simple conversion. So we're going to start with 55 gallons of the solution. And 1 gallon contains 3.785 liters. And parts per billion, let me go up here. Parts per billion, 1 part per billion is equal to 1 microgram per liter. So this will be 50 micrograms per liter, and there's 1 times 10 to the 6th micrograms in 1 liter. And this will equal 1.04 times 10 to the minus 2 grams in a 55-gallon drum of the arsenate. This is the arsenate. That's 3 minus, my bad. The molar mass of arsenate, and I just looked this up, was 138.92 grams per mole. I'll just put it on that one. And 1 mole of ASO4 3 minus and 1 mole of that, but my molar mass will be 207.9 grams of the sodium arsenate per mole. That will equal 1.6 to 2 sig figs to the minus 2 grams per 55-gallon drum. That's part A. Part B talks about some contamination. Let me find this here. This is worth going to read. So in 1993, which is quite a while ago now, naturally occurring arsenic was found in Bangladesh drinking water. And it was found as a major contaminant in Bangladesh. About 12 million people in Bangladesh still drink water from wells that have high concentrations of arsenic. There was a professor from George Mason University was offered a $1 million Granger Challenge Prize for sustainability for coming up with a simple, inexpensive system. Instead of writing inexpensive, I'm going to write cheap. I don't mean cheap in a bad way. For filtering the arsenic. This system uses sands, buckets of, let me rewrite this, buckets of sand, cast iron, activated carbon, and wood chips. The water is run through these buckets, and we have a 90% efficiency, which means that 90% of the arsenic is retained. So 10% of the arsenic passes through and remains in the water. We are asked how many times do we have to pass through the filter? If we start with 500 part per billion arsenic, and we want to get it down to 50 part per billion standard. And that's actually pretty easy. You can probably get this one by looking at it. If we have a 500 part per billion is our starting point, and we multiply that times 10%, which is what will be remaining, which is 0.1, we get it down to 50 parts per billion after the first pass. So we'll be down to passable by removing 90% of the arsenic with only one pass through the filter. And that is it.